Hello and a very warm welcome to Key. Have you ever wondered how an electric car glides so smoothly or how your phone charger is so tiny and efficient? Well, today we're going to shine a light on the hidden heroes that make all of that possible, the amazing chopper circuits.
All right, let's think about this for a second. We're all familiar with transformers, right? They are absolute masters at changing AC voltage levels, stepping it up or down. But what about DC power? How do you take a fixed DC voltage, say from a battery, and change that?
And the answer, my friends, is the chopper circuit. Put simply, this clever device takes a steady, fixed DC input and, well, chops it up to create a variable, controllable DC output. It's basically the transformer's counterpart in the DC world.
But why is this so important? You might be asking, what's the big deal? Well, the thing is, so many of our modern gadgets and machines need a very specific adjustable DC voltage to work properly. But they're often powered by a source that provides only one fixed voltage. Choppers are the perfect bridge for that gap.
You know, looking at this slide really shows you what a leap forward this was. The old way, the AC link was, let's just say, a bit clumsy. You had to convert DC to AC, use a transformer, then convert it back to DC. It was inefficient, bulky, and expensive. The DC chopper, on the other hand, it's a total game changer. One simple step. It's highly efficient, way more economical, and so much more compact.
So how does it pull off this magic trick in just one step? The secret, believe it or not, is incredibly simple. At its very heart, a chopper circuit is really just a super fast electronic switch that can turn on and off thousands or even millions of times per second.
Let's walk through it. It's like a little two-step dance. First, when the switch is on, power flows from the source to the thing you're powering, the load. At the same time, a component called an inductor is busy storing up energy, kind of like charging a tiny battery. Then, boom, the switch turns off. The inductor immediately releases all that stored energy, which keeps the current flowing smoothly to the load. It's a really clever system.
So the really crucial part is how we control all of this. And that brings us to the most important concept of all for choppers, the duty cycle. It sounds technical, but it's just the percentage of time the switch is on during one complete on-off cycle. This right here, this is our control knob.
And this is where it all just clicks into place. The formula is so elegant. The average output voltage you get is simply the duty cycle multiplied by the input voltage. That's it. So if your duty cycle is 50%, your output voltage is half of your input. It gives you incredibly precise control.
This chart makes it crystal clear, doesn't it? Let's say the switch is on for only a quarter of the time, a 25% duty cycle. You get a low average output voltage. You increase that to 50%, the voltage goes up. You push it to 75%, and you get a nice high output voltage. It's a direct, predictable, and beautiful relationship.
Okay, so let's talk about where these circuits are actually working in the real world. Because this isn't just theory, they are everywhere. They control the speed of DC motors in everything from electric cars and trolley buses to massive mine haulers. And they're at the heart of the power supplies in our computers, our TVs, almost all modern electronics.
And their importance is only going to grow. I mean, this quote really says it all. As we move towards an all-electric future for transportation, choppers are absolutely critical. Their incredible efficiency and super fast response time make them the perfect choice for controlling the powerful motors in electric vehicles.
Now, so far, we've mostly talked about the step-down or buck chopper, which lowers the voltage, but that's just scratching the surface. There are also step-up or boost choppers that can increase the voltage, and even buck-boost choppers that can do both. Each one is a whole topic in itself, maybe for a future explainer.
So, that leaves us with a final thought to chew on. Our world is constantly demanding more efficient, more precise control of electrical power for everything. The chopper circuit was a revolutionary step, but what do you think is next? What will be the next great evolution in DC power control?
We really hope this has helped unlock some of the secrets behind chopper circuits for you. If you enjoyed this deep dive and found it useful, please do us a favor and hit that thumbs up button, share it with a friend, and of course, subscribe to Key for more explorations into the fascinating world of technology. Thank you so much for joining us.